IM-5284 calibration, but first a sneak peek at a new project. Good Saturday morning to you, YouTube. Here with you on the workbench at the moment. I do have the Heathkit IM-5284 at my side here, and it is ready to be calibrated. I do have my voltage standard that Bob sent me. I've got it all charged up, ready to go. You can see it works. And also, while I was at it, or not at it, but while I was looking for that, I happened to come upon my little AM transmitter that I built from Bob's design, and I'm planning on putting the rest of that together here very shortly. And as you can see, the antenna is sticking up there. I don't know if you can see it or not, but there's an antenna sticking up. So that's the point where we'll start at, is go from there, put that cap on, and there's a pot that goes there, and trim pot. So like I said, that's what we'll plan to do with that very shortly. Like I said, that's coming up. I've got a sneak peek coming up here of a project that you guys know about it, but I wanted to do a little bit more in-depth look at it. Is the Philco out in the garage, and we're going to take a little journey out there to the garage and take a look at that. We're going to do that before we even get started, so let's go out and see what we got. And to the garage we go. Where we stop, only heaven knows. That first step's a doozy. Alright, well there you can see the Philco sitting there. I don't know, still don't know why it's sitting that way, but it is. So let's turn some light on here so we can see what we're doing. And there's a good look at the back of the chassis, the speaker. Now this being the vintage that it is, it has a fuel coil on the speaker, and that's a good look at the inside of it. Grill cloth doesn't look too bad. I was looking at the stuff you couldn't hardly see, but this is going to be a fun project, I think. This is one type of radio I don't use a lot, or don't get to do a lot. Fuel coil speakers and stuff like that. I can't remember the last one I worked on that had one. You know, I like the transistors and things like that. So let me turn it around. We'll take a look at the front and see what we got there. All right, there is the front. Now trying to do this one-handed. Missing thing is on my computer stand in there in the living room. I've got that to put back on there. There's the tuning dial. You can see the I think you can see the now Gary says that needs to be replaced inside there, which I'm pretty sure Radio Days has those. Like I said, the grill cloth and everything looks pretty darn good, I think. And this is a nice looking cabinet. Somebody refinished it, obviously, I think. I don't think that's original, but it could be. Nothing saying it couldn't be, but whoever did it did a really good job on it, that's for sure. And looks like the escutcheon needs a little bit of work, but it's not bad. It may just be alright like it is. So I'm kind of doing this for Don over at the Restorable Radios. He's kind of the go-to guy as far as I'm concerned on doing stuff like this. Of course, Gary in himself is, you know, does quite a few stuff like this, cabinet work especially. So that's a good look at it. There's Philco. You can see that, I think. So that's this is coming up. So I just kind of wanted to whet your appetite for something like this. What I plan on doing is taking the chassis out and taking that inside, getting that in the speaker itself, and getting that on the bench, and I'll have room for that. Now I don't have room for the whole cabinet in there. I mean, I could put the cabinet in there, but you wouldn't be able to see it on the bench, obviously. So, all right, we're going to go back in the house and see what else is going on. Hi, we're back here on the bench again. I'm going to do some reading from our list here, and I will post up a better look at this than what I'm holding here on the screen, so you can follow along. Note, if a multimeter does not seem to operate properly during any of the following tests, and it says tests there, so I think that's a good clue. Turn it off, immediately refer to case of difficulty, page 38. Refer to pictorial 22 illustration booklet, page 5, and pictorial 17, part A, for the location of the front panel controls and switches in the following steps. Okay, we turn the mechanical zero adjust screw at the bottom of the meter until the meter pointer is directly over the zero indication of the meter face, and we've done that. Set the multimeter front panel switches and controls as follows. Range switch on 1000 volt, we did that. Function to off, we did that. Zero adjust, center of rotation, we did that. Ohms adjust, maximum counterclockwise. And I don't think I did that. I think I put them in both the center of rotation. I don't think it really matters, but set the circuit board controls as follows. Meter adjust, maximum counterclockwise. DC calibration, maximum clockwise. AC calibration, maximum counterclockwise. So we've done that. So let's see what else. Set the line bat switch S3 to line for power supply operation, or bat for 9-volt battery operation. We did that. Well, we didn't actually do that because there's no switch. Prepare the following wires. They were prepared already, so we didn't do that. Note, when you connect the wires, the foil side of the circuit board. Next step, position the insulation on the wire up the foil so the solder can flow into around the bare wire and form a good connection. So we did that, or it was done already. See the inset drawing, we did that. Then cut the excess lead off of the component size. Each will connect wire. That was all done prior to us getting this. Connect the black and red wires to the foil side of the circuit board as follows. Black wire between hole AC, S1, and we can take a look at that on the diagram, and hole Z, and that's where we took it off of where it was at, put it onto hole Z. Red wire, same way, we took it off of where it was at and put it to hole AE, which is the next step. Red wire between hole AF and hole AE. And then turn the function switch to DC plus. Meter should indicate approximately 8 on the black scale. Now, it indicated 8.8 if you recall. And that's exactly what they found to be on their, whoever had drawn these up or posted these, it was 8.8. So note the meter reading on the black scale, we did that. Turn function switch to off, we did that. Connect the white wire, we used a clip lead, and everybody says I shouldn't have used a clip lead, but I did anyway, and I don't think it's going to make that much difference. But anyway, we did that between hole AD and hole and AE. So we've done that. Turn the function switch to DC plus. Turn the meter adjust control to the point where the meter indicates 1/2 the value you noted above, and leave the control at that position. We did that. 4.4. Turn function switch to off. Refer to pictorial 17, part B for the following steps. Remove the end of the black wire. We've done that. And this is, we're talking about this up here on this pictorial 17. And move them back, the red and black wires, to where they want, and remove the white wire, which is a clip lead in our case, and we've done all that. Remove the white wire, that was the part I just talked about. Turn the function switch to DC plus. Turn the zero adjust control, not the mechanical zero, but the front panel fully clockwise. This should cause an upscale reading. It does. It did. Set the function switch to DC minus. Turn the zero adjust control fully counterclockwise. This should cause a meter pointer to move upscale. It does. It did. Readjust zero adjust control for zero indication on the meter. We did that. Alternate the function between DC plus and DC minus. If the meter needle was set exactly on zero, it should remain on zero in either position, and if it does not, repeat the following or preceding steps. Alright, we did that, and I did get it on zero, and it did not move 1 iota. Plug the black lead into the black minus jack and the red lead into the red positive jack on the front panel. That is where we are at right now. So, that brings us to this point here on the DC calibration. That's what we're going to be starting today. As I said, mentioned in the opening part, I do have the little DC standard that Bob sent me, so we'll be using that, and so that's what we're going to do next. So stay tuned for that, and we'll be right back. Alright, what you can see here is the meter is on 0. It is on DC plus. It is set at 10 volts. I have the calibration standard hooked up, and I also have leads from the probe, or from the meter, hooked up to the meter, and then meter from the my Fluke hooked up to those. So I want to get both accounts for it, see what I can get. So I'm going to turn it on, and we're on, like I said, we're on 10 volts. And this first one I touched should be 10 volts, and we'll see what it reads on both meters. Now these leads are just a little bit stiff. Alright, there you can see it's reading a little over 7 volts there. It's reading exactly 10 on the Fluke. So the instructions say to adjust the DC calibration until that goes where it's supposed to be. So we got that on there. Let's go down here like this and get that adjusted right at 10. That is perfect 10 right there. So we're good with that. And you're supposed to make sure it zeros, and it did 0. Let's take it one more time. Perfect 10. Good. Now let's try the 5 volt and see. It should be the same range right here is where it should be coming to, not the AC. That's red is the AC. So let's see what that does. That's pretty close. Let's 5 volts exactly on the Fluke. I'm going to give that tweaking just a hair. And back up a little bit right there. Right there. That's perfect 5 right there. Alright, now let's go for the 10 again, see what that reads. 10 is a little over, so let's go back a little bit. I don't expect it's going to be absolutely perfect. It's not going to obviously be as good as a digital meter, but I'm trying to get this as close as I can. So 5 is good. 10 is... If you look down at it from this angle, it looks perfect. So I'm going to call that good. Let's do the 2.5 just to see. And by gosh, that's right on the money. That is perfect. So there is our DC calibration done. Just that easily. And now the AC calibration will be next. Stand by. Alright, back with you again, YouTube. I have the test set up. Calibration test, I guess, is what I was talking about. We are looking at the voltage reading for the Variac right now. It's at 0.3 on that one, at 0.6 on the Fluke. I did this is the second time I've done this. I messed up the first one. I used the AC, or the DC scale up here on the black. I'm supposed to be using this red scale here for the 10 volt range. So it's the top red scale. The bottom one says 1.2 volt only, so I don't know exactly what that's about. But anyway, that's what that is. Anywho, let's get some voltage here. I want to put 10 volts on it, and that's what I did last time, and then basically went back and forth to get the exactly right, or as close as I could, right? We'll put it that way. And it was a little bit difficult with the I can't not get that. If I move it a little bit, it gives me a... Alright, there we go. 10.03. Now we can see that's obviously not 10.03. It has to come back down some. So AC calibration is here. So let's get it right there on the 10. That is right on the money on 10. So we're at 10.02, 10.01. That's pretty darn close to 10 volts. So let's go for 5 now and see what it looks like. This should go better this time, I think, using the right scale, because obviously 5.02. Alright, just off a little bit. Let's go with a little bit of a, trying to get this the best I can between the two, you know what I'm saying. I don't expect it to be perfect, but there's a little bit under 5 right there. I think that might be just about right. Let's try 10 and see again. There's 10 right there, and you can see it's a little bit over. So I'm just let go of the, it's just so hard to get that right in the spot it needs to be. There you go, 10.05. So that's just a little over. Let's go back down just a hair with it. Alright, just try that right there. Oh, that's down a little too much, actually. It's hard to see that right on the money. There we go. So that's that. Let's try the 9 or the 5 volt one more time. See if we should be close to it. 5.04, and we're just not quite there. I'm going to go one more time, get it just a little closer. Right there. Alright, we're going to try that 510 now once more. It should be just a little bit above 10, I think. There's our 1004, and we are a little bit above it. So I'm going to go back just a hair. I know I'm just, looks like I'm doing this over and over again, but I'm not really. Right there. I'm going to call that good because, like I said, it's just, I can do this all day long, and it's not really going to change that much. So we're going to call that good. I just want it to be close anyway because, I mean, after all, we're not even using this for voltage measurements. We're using it for positioning of the needle when there's more signal fed to it. And that's really all we're using it for. So, alright, let's be done with this, and we'll go back to the other part. Alright, apparently I wasn't filming. So I'm going to just do this real quick again. Basically what I've got here is the ohms adjusted there. If I touch the probes together, we get 0 and full scale the other way. Well, not quite full scale, but close to it. There we go. That's really all you can do as far as, and like I said, I've got a 10K in there right now. It should measure 1 because it's on 10K scale, so it comes up. It looks like about half of that value. So, and I'm sure the resistor is closer than that. Like I said, it's not a big deal. I don't care if the ohms work on this or not. It's just not something I'm going to be using because I've got digital meters that are just so much more accurate that I'll be using those. So we know that it does function anyway, halfway. So that's all we need to do for that. I'm going to call this good. And we'll, you know, like I said, that's basically what we want to use this for. It should be fine. I'll be using it on the 1 volt scale, probably, more than likely, most of the time for radio alignments. And so I'm going to call that good, and I'm going to batten the hatches and put this thing back together, and we'll go from there. We will put this together and put this up on the interwebs, today, and so you guys have a wonderful day. It's now 11:39 in the morning, if I didn't mention the time before. I think I did. You guys have a wonderful day. Thanks so much for watching, and we will see